a blissful day. In this presentation, we will be discussing our research for this subject, Practical Research 2. We, the researchers of this study, are from Grade 12 STEM Knowledge Group 2. Our research is entitled The Comparative Study on the Efficiency of Coconutshell, Cocos Nucifera, Bambusoideae, and Areca nutshell, Areca Cathechu, as strengthening aggregate materials of brick made up of oyster shell or Ostreidae. For brief discussion of our research, the main purpose and the scope will be tackled. One of our main purpose is to create another way of recycling agricultural waste for further innovation of conserving and protecting our nature. We all know how uncontrollable our wastes are and how dangerous its effect for everyone, including animals and other living organisms, as well as for us humans. On the other hand, if materials in constructing houses are way cheaper but has good quality, more people can afford to house themselves. Lastly, as future engineers and architects, we the researchers believe that the progress in industrial or commercial construction and protection and conservation of environment are possible to work hand in hand or side by side. We believe that there's a way of making durable and aesthetically beautiful buildings or infrastructures without destroying or inhalating natural resources we have on Earth. This study focused on knowing and comparing the efficiency of coconut shell, bamboo, and areca nutshell as strengthening aggregates of bricks made up of oyster shell. This research also assessed the relationship between the amount of the added variables and water absorption capacity of the bricks. But before we continue, let me introduce to you the researchers of this study. Ms. Jinky Labajo, Ms. Eder Olao, Mr. Jassal Keneth Quinez, Mr. Railey Gayondato, and yours truly, Ms. Sachi Natascha Misa. The results and conclusion will be started by Ms. Eder Olao.
Hi everyone, I'm Eder Olao. I'm here to present the statement of the problem question number 1 of our research. Trial 1, the added 1/2 cup of coconut shells as strengthening aggregates resulted to 7.69% water absorption capacity. In trial 2, the added 1 cup of coconut shell as strengthening aggregate resulted to the water absorption capacity of 3.85%. In trial 3, the added 1.5 cup of coconut shell as strengthening aggregates resulted to 4% water absorption capacity. As is illustrated on the table 1, the results of the coconut shells as strengthening aggregates shows that the increasing amount of coconut shell from trial 1 to 3 resulted to varied water absorption rate of the bricks. The water absorption ranged from 3% to 7.7%. Thank you.
So for the question number 2, how does the bamboo perform as a strengthening aggregate materials on brick made up of oyster shell in terms of amount of bamboo fiber and water absorption? So the researchers prepared 3 different trials and amount of bamboo as a strengthening aggregate. In trial 1, they added 1/2 cup of bamboo as its containing aggregate result to 7.4% water absorption capacity. In trial 2, they added 1 cup of bamboo as its containing aggregates result to the water absorption capacity of 4.17%. In trial 3, they added 1 and 1/2 cup of bamboo containing aggregates result to 8% of water absorption capacity. So, the results of the bamboo as its containing aggregates indicates that its increasing amount per trial from trial 1 to 3 to varied water absorption rate of the bricks tested. The water absorption rate of the bricks with aggregates range from 4% to 8%. That's all. Thank you.
For research question number 3, we assess Areca nutshells as strengthening aggregate materials through its absorption rate, water absorption rate, and amount we use. We can see in trial 1, with 1/2 cup of Areca nutshells, the rate absorbs 3.85% or 0.385. In trial 2, containing 1 cup of this variable results to 4% or 0.04. While in trial 3 with 1 cup and a half results to 4.17 or 0.0417. Based from these results from question 3, the absorption rate of water from Areca nutshells from trial 1 to 3 as a little difference of changes of amount. So we conclude that the increasing amount of this variable that being input from trial 1 to 3 resulted varied water absorption rate. The water absorption of bricks with the strengthening aggregates materials from Areca nutshells ranges from 3% to 4.2%. The results for this question from 1 to 3 indicates the materials used as strengthening aggregates can affect the rate of water absorption. However, the amount of these said materials input in the sample bricks doesn't show effect on the resulting water absorption rate.
In research question 4 and hypothesis, we aim to assess the relationship between the amount of variables used and the water absorption rate of the bricks. As we can see in table 4, we combined the results from research question 1 to research question 3. This table is used to compute the person R formula. So as we can see, the summation of all the amount used is 9, while the summation of all the water absorption rate is 0.4713. In order to assess the relationship between the amount and the water absorption rate, we use the person R formula, which is this. So as we can see, based from the results, the computed value is negative 2.16, the degree of freedom is 8, and the critical value is 0.632. So as we can see, the computed value is less than the critical value. Therefore, it implies that the amount of the variables and the water absorption rate of the bricks have no relationship. It is concluded that this result is due to the diverse quality of the bamboo, coconutshell, and Areca nutshell used in this research.
The results shows that none of these aggregate materials has reached the accepted standard water absorption rate, which is 12 to 20%. This is due to the size of bricks that are made. The variables used are not the usual aggregates of bricks. The researchers also obtained limited materials due to COVID-19. That's why these bricks are not made in standard size. On the other hand, among these results, bamboo is the most efficient strengthening aggregate in making brick made up of oyster shell because it is the closest to the standard water absorption rate, which is 12. All in all, this research is a good alternative way of recycling agricultural waste towards ecological conservation and protection of nature, as well as a small step for further innovation of environmental friendly engineering and architecture. That's all. Thank you.